Okay, welcome back. In our previous lessons, we took moments from pivot A, and we have said that even if we take moments from pivot B, we will still get the same answer. In other words, moments can be taken from any point and the answers should be the same. So we are going to take moments from pivot B and see if our answers are the same compared to the previous answers that we got. Okay, so applying the principles of moments, we know that the upward forces is equal to the total downward forces. The upward forces are R1 plus R2. What are the downward forces? We have 40, 48, and 32 newtons. So R1 plus R2 is equals to 120 newtons. All right. Okay. The other principle of moment states that total sum of the clockwise moments must be equal to total sum of the anti-clockwise moments. So here, because we are going to take moments from B, we're going to assume that we do not have pivot A. So let's try to draw and see which forces will act clockwise and anti-clockwise in this case. We have R2, we have 0.2 meters, we have 32 newtons, we have 48 newtons, we have 0.3 meters, we have the R1, we have 40 newtons. Let's complete the distances. Okay, 0.5. Okay, so this is pivot B. If we are considering moments from pivot B, we're going to have the 32 newtons force acting like this. So it is a clockwise. Okay, it's going to act clockwise. We're going to have 48 newtons acting like this, so that will be anti-clockwise. We're going to have 40 newtons acting like this. It is also anti-clockwise. For the R2, because it is directly on the pivot that is under consideration, the moment will be 0, so let's just forget that one. For the R1, it is an upward force. It will continue to act upward towards the pivot concerned, so it is clockwise. Okay, all right, so moving on, we know that total clockwise moments must be equal to total anti-clockwise moment. We are taking moments from pivot B. Okay, so what are the clockwise moments? Moment is the product of force and perpendicular distance. So for the 32 newton is a clockwise, so it will be 32 multiplied by what is the distance, the perpendicular distance from the pivot that is under consideration? The 32 Newton is 0.2 meters plus the other clockwise moment is the R1. Okay, and the perpendicular distance from the pivot of consideration will be 0.5 plus 0.3. So that will be R1 into 0.5 plus 0.3. This equals to the anti-clockwise moment. We have the 48 newtons. And what is the perpendicular distance from the pivot B? For the 48 newton, it is only 0.3 meters. So multiply that by 0.3. The other anti-clockwise moment is the 40 newton. So, and let's look at how far is it from pivot B. The 40 newton, you have 0.4, 0.5, 0.3, okay, from pivot B. Okay, we are coming all the way through this distance. So that will be 40 into 0.4, 0.5 plus 0.3. Okay, so 32 times 0.2, that will be 6.4. 0.5 plus 0.3 is 0.8. So we're going to have 0.8 R1 is equals to 48 times 0.3 is 14.4 plus 40 multiplied by, in bracket, 0.4 plus 0.5 plus 0.3 will have 48. Okay, so this is 6.4 plus 0.8 R1 is equals to 14.4. If you add it to 48, you have 62.4. Okay, so let's collect like terms. We'll have 0.8 R1 is equals to 62.4 minus 6.4. We have 0.8 R1 is equal to 62.4 minus 6.4. We'll have 56. So to have R1, you will say 56 divided by 0.8. R1 is equals to 56 divided by 0.8. We have 70 newtons. So from R1 plus R2 equals to 120 newtons, we already know the value of R1 is 70 plus what is R2. Have R2 equals to 120. Then R2 equals to 120 minus 70. R2 is equals to 50 newtons. So you see, it doesn't matter where you take the moments from, the answers will be the same. Okay, thank you very much.